Okay, so last class we were learning about interest, simple interest. Surprise, or maybe not so surprise. Some of you might have noticed that real life actually doesn't work on simple interest, right? Using our idea of interest and simply using math to logic it out, people have found ways to make your money grow bigger and faster, or bigger faster, okay? And so we're going to get a taste of that just to see where the math comes in and how that might look. It will use your knowledge of exponents. It will use your knowledge of interest with principal, blah, blah, blah. Okay? And it will also use your knowledge of percentage. So if you think back, that is a lot of units we've done together. It all sort of comes together. All right, let's talk. Appreciation / depreciation. Wafik's neighbors are moving overseas for work. While away, they have asked him to look after their property. Yes. Oh, my bad. Oh, so you didn't see it. Okay, so again, exponents, interest, and percentage. All of that we have done in the past. Let's see it come together. So Wafik's neighbors are moving overseas for work. While away, they have asked him to look after their property. For his troubles, the neighbors have offered Wafik the following options: $500 a year, or $1 in the first year, $2 in the second year, $4 in the third year, $8 in the fourth year, aka we are doubling. What factors must Wafik consider? Which option should Wafik choose? Show your thinking. Yep. Right. Why? Why? Why should he consider?
Because for option, if using option 1 to pay 2,000, whereas 4 years is option 2.
Okay, so let's talk about the 4 years. I'm going to stop you right there. Let's talk about that 4 years as my template. Okay, so option 1, I get 500. Nice. Another 500. Nice. Another 500. Nice, and another 500. It's not bad, but if I think about what house maintenance is, cutting grass, shoveling snow. Oh, I'm not sure if I would do that for 500 a year, but hey, it's still worth it, I suppose. Okay, 500, 500, 500, 500. So all I have to do really is just keep on adding as I go, right? And it will tell me how much I have so far. Option 2, starting with $1, then $2, and then $4, and then $8, and then 16, 32, 64, 128. Let's do a little bit more. The next one is 256. And then finally, I'm making more than option 1 by year 10, which is not a small amount of time. So if you look at this, it's like, oh, obviously I would want $2,000 instead of what? $15. So this is 2,000 versus 15. And then if I go all the way up to here, the total is $4,000. But here, I have to actually add all this up. 31, 63, 127, and $255. 4,000 versus $255 after 8 years. So yeah, I think it makes sense to go for option 1, but consider this. What about the 11th year? In the 11th year, you make 500, but in option 2, double again. Yep.
In option 2, in the 11th year,
Yeah, that's huge. Oh, you're probably doing exponents. We actually started with 1 being $1. So for you, it might be on the 10th year you make.
oh yes.
Yeah, on the 10th year. So because I started at 1 and not year 0, there it is. And this is 500. And the next year you're making, whoa, in 1 year, I made the same amount that I would have made in 4 years. If you see it, great. If you don't, recognize that the option 2 is using the power of exponents. Here, I'm just adding 500 every step of the way. Here, I am multiplying every step of the way. And hence, at the end of the day, if I go any further than this, it's clear that the amount of money that I will make using option 2 is absolutely more. So, what factors must Lafitte consider? Well, it would be, as we were saying, Lafitte should consider the number of years he must look after the property. Okay, there it is. Thank you. So which option should Lafitte choose? Again, it depends on how many years it is. So I'm not going to ask you to answer that. The point of this idea is, what if instead of adding interest to your final amount, what if you can calculate in a way where you multiply the interest in? So let's talk about your savings account. Looking at this option, which of those two mathematical operations would be more ideal for you? Adding a certain amount in or multiplying a certain amount? Yeah. And hence, as opposed to adding the interest onto principal, we're actually going to multiply a percentage in. And this is where we go from here. It's still recording? Okay, still recording. Take a look. The second option in the warm-up activity is an example of compound interest. With compound interest, you work out the interest based on a percentage. Consider this. Okay. We find the interest for the first period, and then we add it to the total, and then we calculate the interest for the next period. Consider this, okay? In this scenario, I'm not sure how well the image came out, but let's pretend our principal was $1,000, and I gained 10%. Quick math. What is 10% of $1,000? It's written there. Go ahead. 100. So 10%, so if you're not sure how this is happening, $1,000 times 0.10, right? 10% is equal to 0.10. I hope I don't have to explain that. That was part of our percentage unit. So it's 100. So when I add the 10% in, so this is what? P plus I, right? My final amount is 1,100. Next year, I am calculating 10%. Did I change my rate? My R is the same. But what happens to the amount that I'm actually adding on? It increases. This is my argument. Now that I have 1,100, that's my new principal. 1,100 is used to calculate 10%. And so you get $110. You don't get 100, you get 110 this time. So P plus I, it's now 1210. Now this becomes my new principal, and we do it again, and we do it again, and we do it again. Compare. If we did this based on simple interest, I gain $100 and I should gain another 100 next time. So how much more do I earn by using this thing called compound interest? An extra $10. 1210 versus multiplied by 2. Right? What is my interest if I did 1,000, 0.1 times 2 like it was simple interest? Quick math? But I gained $210. The idea of compound interest is this. It's better for us to actually calculate as a comparison using an example. So I'm going to introduce my formula, and I will do example 1 with you, and then I want to compare it with what it would have been if we did simple interest. Okay, here we go. This is my compound interest formula. It is very similar to an exponential, right? It's like the final amount is equal to some value multiplied by the base to the power of x. Does that look familiar? It's an exponent. So here we go. Remember, the A is still the final amount, the future value, the final value. P is still the starting amount, the initial value. My R is still the percentage per year, and time is still in years, but please pay attention to where each of them are placed. We're going to do this example together. Yep.
So so we keep the 1 in the
Correct. Because that 1 represents 100%. So we keep our original 100%, and we're adding another, in this case, let's say 4.2%. Correct. So let's do this example. My principal is 150. My rate per annum is 0.042. How much time? It is 3 years. What's my final amount? Leave some space, please. I want you to know that I want to actually compare this with simple interest right next to it. And you'll see that that little bit of money goes a long way. So if you can, some people might be using their phone calculators. That's going to mess you up unless you're very careful. If you are good at punching in numbers exactly as is, please punch in exactly as is. Other people, maybe you want to calculate the exponent first. Remember, you have to do bracket, and then the exponent, and then multiply by 150 after. You got an answer? Just give everyone a chance to try it. Your final answer should be, some people are working on it. I'll give you another minute. Please make sure you can use your calculator efficiently. People often in my past have made silly mistakes. I just don't want that to happen. Like, I want to give you these marks, but if you make a calculator error, I can't, right? In the least, you'll lose like 0.5. In the most, you might lose like a full 1 or 2 marks, right? What'd you get? 6.5. Oh, you might have rounded. I actually punched this all in. I got a slightly different one. I got 70, but it's very similar to your answer. Don't worry about the slight differences in cents, please. It's okay. But I want to actually use this example to compare with simple interest. If I have PRT here, what would the interest be if I use simple interest? 150, 0.0423. How much do I earn? No? If you did it right, you should have gotten $18.90. So my final amount is 150 plus 18.90, which is 168.90. So if you do the math, you earned a whopping 80 more cents. Whoa. However, this is based on $150 and 3 years. Now think about if we were to base this on, let's say, 1,000, 2,000, 10,000, or even $1 million, and we base it over 30 years as you work towards retirement. For free, essentially, assuming that the rate is dependable. Okay, so this is a difference between simple versus compound. We are not doing simple here. If I ask you to do simple, you must remember that we are using a completely different formula. But majority of stuff that happens in the outside world is based on compound. This part? Oh, the one? The one is a part of the formula and it represents 100%. So imagine my growth rate is a 0. Then it's A equals P times 1 to the power of T. So anything multiplied by 1 is the same. I'm not changing. But if I have 1 plus R, in this case, 1.042, that means I am increasing or multiplying the principal by an extra 4.2% on top of the 1. Right? So I'm actually getting bigger than 1.
So it's instead of adding it together at the end.
Correct. We're multiplying by a percent. It's sort of like tax.
It's like when you do your number plus 8 times 1.7.
Correct. Okay. Credit cards. Credit cards are somewhat similar in that respect. It actually uses a hybrid of compound and simple interest, but it gets really complicated. I'm not going to go into that. But because of this, that's why if you hear any commercials of like, you know, let's solve your debt, let's solve your debt problem, you know, blah, 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 blah. It's because the credit cards use compound interest to take money from you. It's really dangerous to have a credit card debt. Please be careful when you get yourself a credit card when you turn 18. It's a necessary evil, okay? And you can get nice points with it. But if you aren't able to pay it off, it turns into an incredible vortex and it's very difficult to get out. Mark my words, please be careful, okay? A credit card charges compound interest at a rate of, I'm gonna write it down right away, 0.0865, compounded annually. If your credit card bill is 1,000 and you don't pay it off, how much will be owed in 2 years? So my principal debt, I start with 1,000. The time that passes is 2 years. What does that turn into? You know what? Can we change this? This is actually a lie. A credit card usually doesn't charge 8.65 a year. Let's be realistic. An entry-level credit card, when you go to university or college and they snag you as a 17, 18-year-old student, percentage per year is usually about 29.99%.
What?
Per year.
Really?
Yeah. It's 30%. So that's why you have to be good at paying off your credit card. It's a scam, but it's also a necessary evil because they use your credit score for a lot of different things. So let's change this number to 29.99. As a decimal, it's 0.2999. what would be your final amount if you did not pay it off for 2 years and just let it sit there? Let's use a formula. P 1 plus R to the power of T. The final amount is 1,000, 1 plus 0.2999 power of T. You already got it, Nolan? Yeah. Okay, go for it. I just need 2 people to confirm. Use your calculators, please. You got last one. I need 1 more person. Just use your calculator, see if you get the final answer. Let's try it. It's really important to be able to use your calculator. Yeah, you got it? Perfect. We got 2 people. All right. So 2 years, 700 bucks. In 2 years, it's almost doubled your principal. Scary. And it's only going to snowball from here because remember, 29.99% isn't calculating 29.99 off of 1,000. Now it's going to calculate 29.99 from your previous final amount as your new principal. Hence the idea snowballing. I wonder how many people have grasped that idea that compound interest snowballs. The amount that you add gets bigger and bigger and bigger every time, as if you're rolling a snowball down a hill. And the ball gets bigger, 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 without any effort. Okay? Any questions? Once, twice. Okay. If you know this, then we can talk a little bit more about depreciation. So appreciation is not just happy, encouraging words. Appreciation when it comes to money is increasing in value. So the opposite being depreciation, decreasing value. So take a look at the equation, the formula we used here. If appreciation is an addition of a growth rate, then logically a depreciation would be a not addition. That's the only difference. You still use R, you still use P, you still use T, but we are not growing, you're not getting bigger than 100%. We're multiplying by a value smaller than 100%. Let's take a look. I'm pretty sure, yeah, how much will be in the account after 5 years? Same kind of example. Depreciation. Everyone, same A, same P, same R, same T, but it's a subtraction. Take a look at how it's worded differently. Research shows that the value of a certain make of car depreciates at a rate of keyword 0.75% per year. So when you see the word depreciating, you automatically know that we are using this formula. How much will a car that is worth $12,750 be worth in 5 years? That's a mouthful. Let's write down what we know. I know my rate is
0.075.
close, double zeros. How do I know that? Remember, 0.75% is the same as 0.75%, which is 0.0075. Please be careful. Star, star, sad face, scare face. Okay. Okay. Sad face, scare face. How much will the car that is currently worth, so right now, so that's principal, what we start with, and 5 years has passed. Putting this together, final amount is currently this much, 1 minus this for 5 years. So before I ask you to solve it, I'm going to subtract. Using your calculator, if you do 1 minus 0.0075, 9925. Do you notice that now the base is smaller than a 1? You're multiplying by a decimal. It's making your original value smaller than before. That's why it makes sense to have an equation with 1 minus 1. So let's do it. Plugging that in the calculator. 0.9925 to the power of 5 times. What you got? Go ahead. 993. So we round it because it's talking about money. 99. Good. Now that is probably not true in real life unless that brand of car is like a vintage style where the values go down. Typically, when you buy a car and as soon as you drive it out of the driveway, you lose like 30% of its value. You're not going to buy it back at the same price you purchased it, right? But yeah, for the sake of the question, there it is. All right. I'm forgetting if I put, sorry, let me keep that up there while I evaluate this sheet. I wonder if I put a question in there where it asks you to calculate the initial value. Whoa, yes, okay. I think you can do the next example on your own. What I want to do with you together is the very last page. Number 3, the question starts with the value of a machine. For the last page, one of the homework questions, number 3, the value of a machine. Right there. See if I can. All right. Everyone, doing what we've always done, would you please read the question and write down the key information you are going to use. If you're not quite sure what's going on, write this down first and fill it in. If you ever get to grade 11 physics because you're interested, your teacher will probably force you to do this because there's way too many variables to work with. Here we go. This is the very last page, one of the homework questions. Number 3, the value of a machine. The value of a machine in a factory depreciates by 20% a year. What's the R? Michael, I'm pretty sure this is not so fascinating that it has to give you such an amazing face. Okay. Correct. 0.20 per year. At the end of 3 years, there's my time. The price comes down to 12,800. Where does that go? So these questions, a lot of students don't like because it's not just plugging into a number. There is an element of what does that number represent? You have to mix and match. And this question says, at the end of it all, the final amount was 12,800. That's the final amount. So what was the price 3 years ago? Let's plug it into the equation. Am I using A equals P1 plus R or minus R? And why? Why? Say that one more time. Yes, but I could be growing for 3 years. Why is it a subtraction? Yep. It says comes down. Well, yes, it says comes down. Another keyword? Depreciation. It depreciates. Lots of clues to show you that the money was going down. So because it's not growth, but what we call decay, a depreciation.
I understand why it's that, but if you're trying to get back to your original word, something higher than this, why are we using this?
Good question. It's a good connection. Consider the numbers that we have. I have the final amount. I don't have the starting amount.
That's why I wonder why we're adding it back.
You'll see. You'll see. The question was, well, the answer is going to be bigger than what I ended with. So why can't we do a growth backwards? It's a legitimate question, but because we're dealing with exponents and well, essentially exponents, the numbers don't work out too well. And I wish I could give you an example right now just to show, but instead, I hope you're satisfied with this situation. I have 12,800 multiplied by, could someone do that for me? 0.512, one more decimal, because we're dealing with money. Oh, perfect. How do I get P all alone? 3 people, somebody else, the same 3 people. Think algebra. How do I get P all alone? None? No. Now flip it, but think of what's happening. What's happening between P and 0. Yeah. P, both sides have to be divided by 0.512. So when you do it, what's the final? Someone's got it? Pardon? 25,000. Exactly? Yeah. Amazing. So this machine was originally 25,000. So to answer your question, Maddie, instead of multiplying by a bigger percentage, we're actually dividing out that smaller percentage. So if you think about it, up until now, decay, we're multiplied by 0.8. We multiply by 0.8, we multiply by 0.8 to get to a smaller number. To go backwards, we're dividing by 0.8, we're dividing by 0.8, we're dividing by 0.8 to get a bigger number. Okay? And that's it. All of these questions are based on exponential functions. We call it compound interest because the word compounding is essentially the same. We multiply using our most recent amount, not the original principle. And so the formula helps you do that. When you do these questions, let's say in preparation for a quiz, a test, or even an assignment, you have to look for whether it is going to be compounded or whether it's simple interest. The question will tell you exactly what it is. It'll say that it's percentage simple interest or percentage compound interest. Any questions? No? All right, then my expectation, first off, before you go home today, would you try to complete all the examples in this sheet we haven't done together? That's like, what, 2 or 3 different examples? It will force you to read carefully, figure out if it's growth or appreciation or depreciation, use the correct formula, plug in the correct numbers for A, P, R, and T, and practice with the calculator. A lot of stuff is going on. Okay, let's get to it.